Let's start the session. So in the last class, we discussed how to find the resultant force on a particular charge by drawing the parallelogram. Okay. So I will take one or two more questions. All of you comfortable in drawing parallelogram and then applying the resultant formula? These two things are important. So let's solve few more questions. And reminding you guys, Saturday there will be a exam. Okay, which subject? Six. So if you check the timetable, in the timetable it is mentioned every Saturday 7:30 to 9 you have exam. Okay, there may be 1 or 2 days exception that you will not have exam, but regularly you will have exam. So this Saturday you have physics. Whatever we will finish by tomorrow. 15. It will be mix up of MCQ as well as subject. Okay. No, not now. We'll take it after some time when we cover a significant portion. Okay. So question paper will be combination of few subjective questions, few CQs. So 15 to 20 questions on an average, 7:30 to 9. Physics. So try to come for the offline. There's no point of writing online exam. Come and write offline exam. An exam is just to tell you that whatever effort you are putting is enough or not. Never think, don't hesitate in writing exam because I see that in the starting 5 6 months, not me, you will only see very few of you will write exams. It's a trend. Then slowly, more people come when they see that exams are close. So write exams, never miss exam. If you're prepared 60% also come and write the exam. It will just tell you that I'm not putting enough effort. Or if you're putting enough effort, very good. It will motivate you. In both the ways, you will get motivated to study more, to clear your doubts, to revise the concept regularly. Write exam, never miss exam. Until unless something urgent is there, you can skip and you can ask for a new date. You can come and write. Sure, all of you copy the question. The first problem. So it is an equilateral triangle. We discussed the equilateral triangle problem already. We are discussing one more. This is A, this is B, this is C. Now the charge at A is Q, the charge at B is also Q, and the charge at C is minus Q. This is the figure given in the question. Make a note. ABC is an equilateral triangle whose side is L. ABC is an equilateral triangle whose side is L. Now the question says, what is the net force on each charge? What is the net force on each charge? So you need to do the calculation for charge at A, charge at B, and charge at C. All of it try at least, just give an attempt. If we do the calculation for charge at A, who will apply the force on charge at A? This charge. So Q2 will repel or attract? Repel. So when it repels, the direction will be this one. So this is the force due to B. This is negative, this is positive. So C will attract it. C will attract. So this is FC, right? So how do you find the resultant? We complete a parallelogram. So the diagonal will be the resultant. Now, in equilateral triangle, what is the angle? 60. So what will be this angle? 120. Okay. If you remember the last session, I gave one point. If we have two equal vectors, listen to the statement carefully. I'm repeating again. If we have two equal vectors having angle 120-degree between them, the resultant will be same as one of the vectors. So if this is F, this is F, angle between them is 120, the resultant will be again F. And that's what we proved also through one question. So suppose if it is a MCQ, don't waste your time. Directly say F. Okay? When angle is 120 and both the vectors have same magnitude, if I see FB and FC ka magnitude will be same, direction is different, magnitude will be same. What will be the magnitude? K Q1 Q2 by L square. So K Q square by L square. Here magnitude will be same. Direction is opposite. It's different because it is minus. Magnitude will be again K Q1 Q2 by L square. Magnitude is same. Angle 120. What will be the answer? This only. Okay. But if it is subjective, then you will do the working. MCQ may save your time. What will be the resultant at A? F square plus F square, which is FB square plus FC square plus 2 times of FB, FC. What is the angle? 120. What is cos 120? What is cos 120?
-1/2.
Minus 1 by 2. So FB and FC are same. So this becomes F square plus 2F square. Cos 120 minus 1 by 2. 2 gets cancelled. So 2F square minus F square? F square, which is F itself. What is the answer? KQ square by L square. Any doubts? All clear? Anyone having questions? Anyone? Now, do we need to do the calculation for Q2? It will be same, symmetrical case. Use your common sense. Common sense says ki sir, charge is symmetrical, distance is same. So whatever you have drawn here, same thing will be drawn on this side. So that I am not doing, that you can do on your own. Okay. So what will be the resultant on this? Same as this one. And the direction will be like this. You complete the parallelogram, diagonal will be like this, right? Okay. So you can leave 3-4 lines for charge at B. Answer will be exactly same because case is symmetrical. Only the parallelogram will be drawn on this side. You can do that at home. I will explain for C. Okay. All of you see on the board. Stop writing. I want to find force on C. This is negative, this is positive. So this will be attracted. So force due to A. Negative, positive, attracted. What is this angle? 60. Equilateral triangle. You will do what? Complete a parallelogram. Complete it. The resultant will be the diagonal. A will track this, attracting. B will attract this, attracting. What is the doubt in direction? Hmm. You're finding the force on this, right? Huh. Now calculate all of you. Hello. Okay, now I'll send the paper in the group. Okay. Yeah, yeah, yeah. They are coming. They came off. I will send the paper on the group. He can attend on. You can you can just ask her to scan it, send to me. I'll correct after that. Yeah. Once she's finished, she can send me personally. I will correct and tell you how much she scored. Okay, okay, I'll send. What is the answer for this one? You haven't got the answer for the force on C?
Sir, is it root 3 kq square by L square?
Root 3F. Root 3F will be the answer.
So I have a doubt.
Yeah, tell me.
So the direction, why is it towards the plus charge? Doesn't it travel from positive to negative?
See, you are thinking of the direction of electric field. Understand the difference.
Okay.
You are getting confused with the direction of electric field.
Yes.
What they're asking is, what is the force on C? So who is
Right.
applying force on C? B. So B will pull it.
Right, right,
Who is applying force on C? A. Because they are
right.
opposite, so it will be pulled.
Yes, got it.
Don't get confused with the direction of electric field. Okay, all clear? Yes. What is the answer coming? Solving. Root 3F. It will take 15 seconds. See here, you guys have already done this. Just substitute cos 120 with cos 60, right? So it will hardly take, I think, 15 seconds. Cos 60 is how much? 1 by 2. 2 and 2 will get cancelled. F 2f square plus f square root 3f. You can do this on fingertips also. Okay, no need to write. That's what I'm telling. See, MCQ or subjective, same question can be asked as a MCQ. You need to be prepared by both the modes. They ask you to write step, you write step. Try to imagine this formula in your mind without writing any step. Tell the answer. The skill is must, especially for those students. I think most of you will write entrance exam, right? Whatever entrance exam it is. All of you want to go to engineering or medical college, any college. For that, you need speed. Syllabus is same. Speed is the difference. Same. One student will take 2 minutes to solve this. Other student can solve within 1 minute. That is the difference. That's it. No other difference. Just focus on the speed, and then you see that you'll be more confident. You will feel that I can solve these things without writing. Confidence will increase your interest also. Okay, when you start getting the answer, automatically interest creates. So for C, anyone who is stuck can see here FA square plus FB square plus 2 times of FA, FB. What is the angle this time? 60. Cos 60 is 1 by 2. 2 will get cancelled. Is the magnitude same or different? Same. Because charge is same. Distance is same. So obviously force will be same. So F square, 2F square. Here 2 and 1 by 2 will get cancelled. So F into F will be F square. So this will be root 3 F. And what is F equal to? So root 3 times of kq square by L square newtons. So I hope that now these kind of questions you can easily
Sir,
manage. These questions are not considered as tough. These are easy questions. Okay? Yes, tell me, what is the doubt?
sir, how do you remove FA and FB? I don't understand.
How did I remove? I didn't remove FA
So
and
because of the
FB.
same magnitude.
Yeah, they have same magnitude. We proved right here. Check FA and FB. KQ into Q. KQ square by L square. Check FB. KQ into Q. KQ square by L square. They have the same magnitude. So I am telling that that magnitude is F. So I replace that by F.
Okay.
If you don't want to replace by F, you can write FA only by telling that FA and FB are equal. So your answer will be root 3 times of FA, where FA is equal to this. Any other questions? Okay. Next one, all of you copy the question. So now we will change the shape. We took triangle. Now it can be a square also. It can be a rectangle also. It can be a hexagon also. So hexagon wala question we will do on the weekend. Now I'm giving the square thing. So this question you will find in your NCRT exercise. So all of you copy the question. The question is, we have 4 charges. A, B, C, and D. And this is a square. Make a note, this is a square. So 4 equal charge Q1, Q2, Q3, and Q4 are present on the vertex of a square whose side is 0.2 meter. Calculate the force on any charge. Calculate the force on any charge. Q1 is equal to Q2 is equal to Q3 is equal to Q4 is equal to 16 microcoulombs. All of you try this. Know the direction, then find the resultant. Any doubts? I sent you for Aditi also. Have you checked? Aditi. This is maths. She has written, right? This is maths. I think this will be physics or chemistry. Same subjects, different subjects. So 3 files I have sent. This one is math, other one will be chemistry and physics. Doubts in the paper? No? Simple? Paper is simple, right? Whatever we did in the class. You can choose any charge. Which charge did you guys choose? Q4? So you guys chose Q1. So there will be how many forces on Q1? Three. If three charges are there, how come two force? How many charges will apply force on Q1? Three, right? Two along the side, one along the diagonal. So if you choose Q1, who will apply force on Q1? Q2 will repel up, Q4 will repel left, and Q3 will repel along the diagonal. Okay. It's a simple question. See, apply the funda. Fundas will not change. I will change the shape. Will the concept change? No. So you guys have, all of you have decided Q1. Okay. I'm taking Q4. Okay. It doesn't matter because all the charges are same. Because I don't have space to draw parallelogram there, so I'm taking Q4. So Q1 will repel. So this is the force due to Q1, or you can say FA. This will also repel. So repel FC. This is positive, this is positive. This will also repel. So this will be FB. Any problem in drawing this? Simple, straightforward thing. Now tell me that the magnitude of FA and FC will be same or different? Same.
Same.
See, I am taking questions which are symmetrical. Because I don't want to complicate things in the starting. Don't start assuming that all the questions will be like that. So you guys know how to find the magnitude, right? You can find out, but here what I'm observing, it is same, so I'm taking directly. Because charge ka magnitude is same, square, so distance is same. So FA will be how much? K Q square divided by, what is the distance? 0.2 whole square. FC will be also same. I'm telling that FA FC is equal to FB will not be equal because distance is different. What is the distance? Diagonal. What is the length of the diagonal of a square? Root 2 times the side. The diagonal of a square is square root of 2 times the side. You can calculate by using Pythagoras theorem. These two sides are known. This is the hypotenuse. You can calculate by using Pythagoras theorem, but we should know these things you are learning from 9th and 10th grade. So this should be 0.2 times of root 2, or you can say root 2 times the side. That is the diagonal. So what will be FB? KQ square divided by root 2 into 0.2 ka whole square. So root 2 ka whole square is 2. So this will be 1 by 2 times of F. Because the remaining thing is same as F, right? What is the extra thing? 2. Clear? So now, can anyone tell me in the class what should we do after this? I want you guys to help me. What should we do? Yeah, sure, yeah, tell me.
So can we use cos 45 for FB because direction and
Cos
then add
45
them?
for FB. First, you will solve
Yes.
FA and FC, na?
So isn't that
Solve FA,
F0?
FC.
Sorry, isn't that cos 0 anywhere?
Cos 0
So
for what?
it'll be the
It's
for
cos
calculating
90.
the magnitude of the force.
See, what we will do first, we will find the resultant of FA and FC.
Okay, yeah.
The resultant of FA and FC will be along FB only.
Right. Yeah.
Okay. When
Yes,
you
sir. Okay.
complete the parallelogram, here the parallelogram will be same as a rectangle or square because the angle is how much? 90 degree. If one
Yes.
of the angle in the parallelogram is 90, either it is a rectangle or square. Here the adjacent sides are equal, so it will be what? A square. Okay.
Yes.
So resultant of FA and FC will be along FB. So what will be the net force? The resultant of FAFC plus FB. Getting it? Any
Yes.
doubt?
Sir,
Any
so it would
student?
be 3 by 2 F.
3 by 2. Why 3 by 2? How come 3 by 2 will come? The resultant of FA and FC will be root 2F.
Okay, sir, got it.
The resultant of FA and FC will be root 2F. This is F. This is F. This is the basics of vectors. You guys have done in Newton's law of motion also. So if you complete the parallelogram, this is the resultant. So this resultant will be what? F square plus F square, which is how much? Root 2F. So what is the net force? A resultant of B, not B, resultant of A and C, which is root 2F, and we already have a force in the direction, which is what?
1 by
FB,
2.
which is 1 by 2F. So the answer will be root 2 plus 1 by 2F. And what is F? KQ square by 0.2 ka whole square. So 0.2 means what? 2 into 10 to the power how much? Sorry, 4. 2 ka square is 4. 10 to the power how much? Minus 2. Calculation I'm not doing. I am leaving for you guys. I hope that you guys can do the calculation. What calculation? K is 9 into 10 to the power 9. Q square 16 into 10 to the power minus 6 ka square. It is microcoulomb. Chalo, let's do it only. You guys are solving. I will also solve. 9 into 10 to the power 9 q square. 16 square is how much? 256 into 10 to the power minus 12 by 4 into 10 to the power minus 2. You can simplify this. No need to simplify this. You can leave it like this. Check the solution. Whatever doubt you guys have, clarify. Don't keep any doubt. Ask at that instant. And do write your notes. Whatever we are discussing, it should be properly copied. Anyone got the final answer? Calculate, calculate. You guys have to calculate. 4, 6 are 24, 4, 4 are 16. Root 2 is 1.4 approximately, 0.5. So 9 fours are 36, 9 6 are 54, 54 plus 3, 57. This will be 10 to the power minus 3, minus 1, right? 1.9 into 57.6.
Sir, I'm getting it around 110.25 newtons, sir.
Yeah, it should be close to 110.
Yes, yes, yeah.
It should be close to 110 when you multiply. Exactly 110.3 or 110.4. Same kind of question they can ask you as a rectangle. If it is a rectangle, then will the magnitude be same? No, it will be different. So the calculation will become more lengthy. Here you directly wrote root 2 f and f. वहाँ पे you have to calculate each, substitute. That is the reason they don't give. Because already it's a lengthy question, you can see. If I make it as a rectangle, your calculation concept will not be difficult. only calculation will be lengthy. So there is no point of doing that. Okay, all of you write down the heading electric field. We're starting the next topic, electric field. Let's understand first what is the meaning of electric field. Then we'll discuss the formulas. I think in grade 10, have you guys heard of this term electric field in current electricity? Okay, some of you may have heard, some of you may not have. But magnetic field, all of you have read about. What is magnetic field? There is a magnet or a substance having magnetic properties creates a region around it, right? Yeah. It creates a region. That is a reason it is called field. What is the meaning of field? Suppose if I say cricket field, it is a place where you go and play cricket, or football ground or field. You go and play football. The same thing is here. If there is a magnet, it will create a region around it. The moment you bring any other magnetic substance in that region, what will happen? It will experience a magnetic force. Same funda is here. Instead of a magnet, I will take what? A charge. Okay, no need to copy anything as of now, just understand. If I take a positive charge by default, positive. So this charge will have the capacity create a region around it. Suppose this board is there, this charge is present in the board. So it creates a region on this board. And if I try to bring any other charge on this board, what will happen? This charge which is coming on this region or board, that charge either will be attracted or repelled. Okay? Are you guys getting? That's what is electric. Simple. No need to remember any definition. If you focus on the name itself, it is telling you, boss, it is what? Electric is taken from electron or a charge. Field is the region around it. So every charge at rest, we are talking about charge at rest. We are not talking about charge in motion. Okay? That's why this chapter is called electrostatics also. I'm not moving this charge. So any charge at rest has the ability create a region around it which is called electric field. And what is special about that region? If you bring any other charge into that, it will experience a force. It is called electrostatic force or electric force. That's it. This is a simple story of electric field. Now, one question was that I wanted to ask, I forgot. I think when I remember, I will ask completely. I was going to ask, suddenly I forgot. Okay. So let's write down the definition first. I remember the question. If the charge is at rest, it will create electric field. The question is, if the charge is moving, will it create electric field or not? I was expecting you guys will ask. It will create what? It will create electric field. And how it will be different from the electric field due to a stationary charge? Will it be same? Because you have an extra characteristic, right? That I am moving also. If I am moving, obviously I should contribute more. What happens if a charge moves? When a charge is moving, listen to the statement carefully. We'll discuss this again in moving charge and magnetism. If a charge is moving, it has the ability to create electric field as well as magnetic field. Okay? So if charge is at rest, it will create only electric field. If charge is moving, it has the ability to create electric field as well as magnetic field. So I will not go in more depth of that. That we will discuss in magnetism. Okay? But you can make a note. A stationary charge creates electric field. A stationary charge creates electric field around it. and a moving charge can create electric as well as magnetic field. Got it? All clear? Any doubts? So let's draw a charge here. So this will create an electric field. I'm drawing a random hypothetical shape of the electric field. Don't assume that electric field should be always concentric circles. I am drawing a hypothetical surface. So this is the electric field around it. So what is this plus Q? This is source. Source of what? Source of electric field. This charge is responsible for electric field. Now what I'm saying that, boss, I want a charge to enter into this magnetic field, not magnetic, electric field. So I am bringing a charge. This charge is Q naught. This charge is trying to enter into this electric field. So this is called test charge. Why it is called test charge? Because this charge tests the strength of the electric field. By using this charge, you can tell that how strong the electric field is. That is the reason this charge is called test charge. Everything has a reason. This is called source because it is responsible for creating this electric field. This is called test charge because this charge is responsible for telling you what is the strength of the electric field. Okay. So this test charge will try to enter. So what it will experience? Electric force. It will experience a electric force. So if you guys are copying, copy quickly. We'll discuss the formula now. Written? Now what is electric field? A formula. So electric field is first of all a vector quantity. So electric field is F by Q naught. And there is one more term here, limit Q naught tending to 0. So if you want to ignore this limit, students who don't have maths, if you want to ignore this limit ka part, you can ignore. But mathematics student can aram se understand this. I'm repeating again, student who don't have maths can ignore the limit part. So what is the meaning of this limit part? This limit part says that this charge is very small. Okay. Not only physics, students who don't have maths, if math student want to also ignore, you can ignore limits. Okay. I don't want to again make it complicated. In simple words, let's simplify this. The meaning of this operator, limit operator, is to tell you that this charge is very, very small. That is the meaning of Q naught tending to 0. Means it is suppose 0.001 coulombs or 0.0005 coulombs. Okay, or you can say 5 microcoulomb, 5 into 10 to the power minus 6. Okay. So what you need to remember, test charge should be always be very, very small. So this is a question which has been very commonly asked in your exam. Explain the reason why test charge should be small. What will happen if I take test charge being a significant value? Suppose the test charge has significant value. What will happen? Listen to the explanation. Anyone knows the reason? Electric field will be smaller.
So the charge which it'll attract the charge.
No, there's nothing with attraction. Attract to attract. If it is a small charge, it will not attract. Attraction will be if I take this as a small negative charge, it will attract. If I take big negative charge, still it will attract. The question what I'm asking, why is it necessary? It's not that few times you will say I will take test charge small. In other case, you say I will take test charge big. It is necessary for us to take test charge to be very, very small. Listen to the explanation. It's very obvious. After listening to the explanation, you will say it is common sense. It's not physics. Test charge is used for what? For testing the strength of this electric field. Okay. If I take a significant value of Q naught, it will have its own electric field also. What will happen? Both the electric fields start getting mixed up. But what is my purpose here? Not to mix, to tell what is the strength. So if I have to find the strength of this, I have to make sure that I don't create one more electric field, which will interfere with this. And what will happen? You will get a wrong value. You will get a wrong information. Understanding? I will say that boss, take this charge as a value which is very small. So the strength of the electric field due to this will be negligible. It will not interfere with this. Isn't it obvious? You feel that it should be like that. It's like that. I'll give a real life example. Suppose you go to someone and tell your problem. Okay? So rather than listening to you, that person also start telling their problem. So will you get a solution? You will be more confused. Should I came here to find the solution and that person is telling their problem only. Okay? So same situation is here. You want to find the strength of this. So that's why this charge is coming here. If this charge also bring its own electric field, both will get mixed up. So we will get the wrong value, wrong output. Clear? Okay. So let's write down the explanation. So first write down the question, why the test charge should be very small, or why the test charge should be small. Question is why the test charge should be small. So the reason is if the test charge is not small, then the electric field of test charge will interfere with the existing electric field of Q and hence will give the wrong value of electric field due to Q. And what is Q? Source. You can write the explanation in your own words also. I just wrote if you want to copy. But don't try to mug up everything. That's what, see, I try to explain in very simple words so that you remember for long time. Because this is a common problem. We say that, sir, we forget very frequently. I've already commented on this. We forget because our mindset is different. Our mindset is just to write in the exam. Study the subject with respect to understanding, to feel the concept, to apply it. You'll feel that you study for 2 times and you're remembering throughout the grade work. You'll not forget. For the moment you see, you remember. So don't try to mug up everything. Things will start becoming better for you with time. So electric field is force divided by charge. Which charge? Source or test? Test. Okay. Now, sometimes we get confused. We say, sir, I get confused that I should divide by test or source. Again, let me make it very obvious for you that you have to divide by test. If you divide by source, what will happen? The source charge in the force and the source in the denominator will get cancelled. Who will create electric field? If you're cancelling source itself, who will create electric field? Isn't it obvious that it has to be divided by test? Because source should be there. So when you write force ka expression, it will be K into source into test by R square. So you have to divide by test because you cannot cancel source. If source is not there, then how come electric field will exist? Again, it is obvious it has to be divided by test charge. So don't say that, sir, I got confused. I divided by wrong charge. You are getting confused because you are remembering. Find out the reason. So what will be the electric field due to a point charge? The electric field due to a point charge is K Q Q naught by R square. So what is this force? Divided by which charge? Test or source? Test. Q naught cancel. KQ by R square. This is the electric field due to a charge Q. KQ by R square. So everything will be very smooth in this chapter. The moment chapter gets over, you will see all the formulas will look similar. First and second chapter when we finish, you will tell ki sir all the formulas are similar. In one formula, charge is removed. In one formula, distance will be removed. The moment we start the second chapter, you will see two formulas, K Q1 Q2 by R square. Okay, which is force. Then you will see a formula K Q by R. Then you will see a formula K Q1 Q2 by R. All the formulas, when you combine, you will feel that all the formulas are looking same. Okay, so you need to take care of these things. Why one part is removed. So rather than remembering this, what I suggest to student that you remember this. If you remember this, you can aram se tell that this will be the formula of electric field. Okay, so do not try to remember exactly the final expression from where it is obtained. Remember that, that will be more fruitful. You will not get confused. Next question, find the dimensional formula for electric field. Question is, find the dimensional formula for electric field. I want you guys to try. You will use what? This one. By Q. Force ka dimensional formula I asked you guys to remember. L1 T to the power minus 2. What is the dimensional formula for charge? AT. AT. Why it is not revised? Dimensional formula for charge is AT. Substitute, find out the answer. L to the power minus 1. How come L to the power minus 1 will come?
Sir, is it MLT per minus 3, A per minus 1?
We'll discuss 1 second. Electric field is basically force by charge. So M1 L1 t to the power minus 2 is for force, and for charge it is what? AT, current into time. So this will be M1 L1 t to the power minus 3 a to the power. Now this is a vector quantity, I already told. What will be the SI unit? Newton per coulomb. Force by charge. Newton per. It is a vector quantity we already discussed. So now we'll start solving the questions. Theory of electric field is over. One thing is there, the direction part. Let's discuss the direction, then we will start solving questions. So electric field is force by test charge. Okay. All of you just observe one thing. Electric field is force by test charge. If I take the test charge on the left side, okay, so what can I say? Force is equal to Q into E. I can say that. I'm going to discuss the direction part because electric field is a vector quantity. You need to know the direction. So I will just cross multiply. See this expression. I will just cross multiply. So I will say that F is equal to how much? Q into E. So the vector on the left side and the vector on the right side are equal. When do we say two vectors are equal? When the direction and the magnitude both are same. Correct? So if I say force ka magnitude is 5 Newton or 5, electric field is minus 5. Electric field is minus 5. Magnitude is same, but is the direction same? No. So can you call them equal vectors? We'll call them opposite vectors, or you can call it as anti-parallel. If, listen to the statement carefully, if this charge is positive, then the direction of force and electric field will be same or different? How different? If
Same.
this is positive, means force is positive and electric field is positive. Because this charge, suppose this charge is proton. Let's assume that I want to find out what is the force on proton. Okay, proton is a positive charge. So here there is a positive term written. So F and E will be in same direction. The moment I say that charge is electron, this charge will be plus or minus. So F is equal to negative of electric field. So direction is same or opposite? Opposite. You need to remember this. This is basics of vector, yeah. This is basics of vector. If I say that A is equal to minus 2 times of B, I know that A and B ka direction is opposite. If I say A is equal to 2B, I know that because it is positive, A and B ka direction is same. Okay? But we remember this. I have seen in textbook also, and I have seen students all they say, sir, positive charge, direction of force and electric field will be same. So you don't have to mug up that. Just remember the basics of vector. You will feel that it is again basics of physics. This is not a point to be mugged up. So I don't want any one of you to mug up, and I don't want you to mix up in the exam. Sir, I got confused. You're getting confused because you are remembering. Always remember it is basics of vector. Positive charge, if this is Q, 2 coulomb, same direction. If this is minus 2 coulomb, because minus is there, opposite direction. So you can write down the statement for your reference. What statement will you write? If the charge is positive, direction of force and electric field is same. If charge is negative, direction of force and electric field is opposite. Any doubts? यहाँ पे है ना यार, do rough here. हाँ ठीक है, it's okay. You can do rough in the question paper also. There is a lot of space on the back side. Suraj, कितना time हो रहा है? 15 more minutes. So do first what you know. 7:15 पे exactly paper ले लो. My mistake? Is it my fault? You came late. Yesterday also I told to come on time. It'll take 5 minutes extra. Suraj, 5 minutes extra. Didn't? Okay. So you guys have written this concept, so direction will be clear now. So if positive charge is there, the direction of force and the direction of electric field on that will be same. For negative charge, force will be opposite to the direction of electric field. So let's solve a question on this. The question what I'm giving is very commonly asked in your exams, any exam, school, entrance, in all the exams, this question has been asked. This question you will find in your NCRT also in the examples, not in the exercise. All of you draw the figure. There are two parts in this. We're discussing the first part. Second part will be homework for you. So we have two parallel plates. We have two parallel plates. The upper plate is negatively charged and the lower plate is positively charged. Okay, this is the thing. So question is, an electron falls to a distance of 1.5 centimeter through an electric field of 2 into 10 to the power 4 Newton per coulomb. Calculate the time of fall. So what is the distance? This distance given 1.5 centimeter. So you need to calculate the time of fall. So first of all, we need to draw the direction of electric field. Direction of electric field is not given. Listen to me carefully. One important statement. Electric field moves away from the positive charge and goes towards the negative charge. Okay. I'm repeating the statement again. If you have a positive charge, you can draw this also. Suppose we have a positive charge. Electric field line always moves away from the positive charge. Field line moves away from the positive charge. Okay. For a negative charge, electric field lines are always towards. Clear? Make a note of this diagram quickly and write down the statement also. For a positive charge, electric field lines will move away from it. With respect to negative, field lines will come towards it. This is the direction of electric field lines. Done? Anyone copying? I'm erasing this part, so I'm asking. Chalo, let's solve this question now. So now tell me, what will be the direction of electric field? Up or down? Up. Positive to negative. Positive to negative. Okay. Just now we discussed, start from positive means with respect to positive, it will move away. With respect to negative, it will come towards. So if you see the direction of the line, this line is going towards negative or away from negative? Towards. With respect to positive, lines are going away or towards? Away. For positive, it is going away. If you see with respect to negative, it means it is coming towards negative. So sometimes they give the direction, sometimes they don't. So you should be able to know it. I have dropped an electron. There is an electron. An electron is dropped. Okay? In this region, our electron is dropped. If something is dropped, what is the initial velocity? Zero. Okay? If you go to the terrace and drop a ball, initial velocity is zero. Now, what is the acceleration? Acceleration due to gravity. But here, you don't have gravitational field. Here you have which field? Electric field. You have to be careful. And this can be a doubt also. He said till grade 11 I was solving everything under gravity. This time I am telling that boss, gravitational field is not here. Here what is dominating? Electric field. And we will understand the difference also, that if I drop a charged body in a gravity or within the gravitational field, what is the time taken? If I take the same charge inside electric field, what is the time taken? So we will observe the difference. This was asked as assertion reason in your JEE advanced exam. They pick a assertion reason from this question and asked you directly from NCERT. But everyone was thinking numerical will come, but they picked the concept. Okay, so you need to understand everything till depth. So let's solve it. So electron is coming down. This is a negative charge. What will be the direction of force? Just now we discussed. This is a negative charge. What will be the direction of force? Opposite to
Opposite of
electric
the
field.
electric field.
Correct. Opposite to electric field. So force will be in the downward direction. So force on this will be in downward direction because negative charge, force will be opposite to electric field. Is the direction ka part clear to everyone in the class? How to draw electric field, how to find force ka direction. Now, what is the basic formula for force? F equals to ma. What will be A equal to? F by m. What is the force on a charged particle in electric field? Q into E. Just now we saw force on a charged particle in electric field is Q into E. So QE by M. What is the charge? Electron. So EE by M. Any questions? You will not find a single thing in the solution which you don't know. You know everything. But the problem is we need to learn how to connect them. Now I will use equations of motion because I need what? Time. So what is given to me? Distance. Listen to me carefully. Distance is given. Okay. Initial velocity is 0. Acceleration I calculated. So which equation of motion? S equal to ut plus half at square. Okay. S equal to ut plus half at square. So all of you use that. Substitute A, calculate time. Use S equal to ut plus half at square. S is 1.5 centimeter. Hello. Hello. हाँ उसमें एग्जाम है 12th का हाँ वो क्लास है किस किसका है अच्छा ठीक है, मैं चेक कर लेता हूँ क्लास में, देख लो 12th का चलो। What? Mass will be given in the. You just write down the expression and leave it. I just want the expression, that's it. Mass will be given in the exam. You don't have to remember. What's the expression coming? S equal to ut plus half at square. So drop initial velocity is 0. S equals to half at square. So what will be the expression? 2s by a, which is p. Correct? Cross multiply and then take. So when you substitute a, so t will be equal to what? 2s by charge electric field by mass. So time will be 2s m divided by. Okay, I'll check it. So all of you see the time thing. See the expression for time. So the time taken depends upon what? The distance moved. The more distance, more time taken. Directly proportional to mass. Heavier the charge particle, more time taken. Inversely proportional to charge. Higher the magnitude, lesser the time. Inversely proportional to electric field. Higher the electric field, lesser the time. So by seeing this expression, you should be able to tell that with which it is directly proportional and with respect to what it is inversely proportional. A direct question can be asked. Now, how to calculate the exact value? Everything is given to you. Distance is 1.5 centimeter. Convert that into meter. Substitute. Charge an electron 1.6 into 10 to the power minus 9. Electric field mentioned in the question. Mass will be given. Any one of you remember the mass? 9.1 into 10 to the power minus 31 kg. You are not supposed to remember this. It will be given. Now, one more thing. Whenever under root and all is there, approximate it to 9 and then do. Okay? You write 9.1, but when you're doing the calculation, you don't show that you're taking 9. Okay? You have to be a bit smart. Take 3. The difference will be very small. Okay? Because square root of 9 you can directly take as 3. Three into 10 to the power 6. 10 to the power 6 or 10 to the power minus 6? It cannot be that much time. 10 to the power 6. Are you thinking how much time it will take? 10 to the power 6 seconds to travel 1.5 centimeter. No, the answer should be 10 to the power negative. Time will be very less. Distance is very small, 1.5 centimeter. The answer for the first part is 3 into 10 to the power minus 9. 3 into 10 to the power minus 9.
Yes, sir. I'm getting it as 3 into 10 to the power of 9 minus 9.
3 into the power minus 9. 10 to the power minus 9 is the approximate answer. 3 into 10 to the power minus 9. I'm repeating again that you need to know how to find the square root. Okay. Anyone who has forgotten, do revise it. You learned how to find the square root in grade 7th or 8th. If you have forgotten, do revise. Square root ka calculation will be in every chapter. Okay. All of you come back from school by 4, right? 4, 4:30. Observe one thing here. The time taken by the charged particle to move in the electric field depends upon the mass or not? Yes, it depends. Now let's talk about gravity. In gravity, you would have heard that if you drop a ball or in vacuum, but gravity is there in vacuum. You drop a paper ball or you drop a iron ball. Which one will hit the surface first? Both will hit together in vacuum. Okay. In vacuum, the iron ball and the paper ball, if you drop from the same height, both of them will hit the ground at the same time. Time taken by the object in the gravitational field is independent of mass. Okay, this thing you're learning from ninth grade. But here, time taken by the object or particle in an electric field depends upon the mass. So this is a difference in electric field and gravitational field. So make a note of the point. Time taken by the particle to move in an electric field depends upon the mass. But in a gravitational field, it is independent of the mass. And the proof is in front of you. It is depending on mass. And gravity wala thing to you guys know already. It doesn't depend on the mass in vacuum. Time taken by the particle to move in electric field depends upon the mass of the particle. But in gravitational field, time taken is independent of the mass. Okay. Any doubt as of now? All things clear? Perfect. Copy the next question. We have two charges. Q1, which is plus 4 microcoulomb. Q2, which is plus 1 microcoulomb. there is a charge Q1 and Q2 on the end. So we need to find out the distance between them is 2. This type of question we did for force also. So you need to find the point on the line joining at which net electric field will be 0. You guys remember the statement we discussed that the point at which net force will be 0 should be always closer to which charge? Charge of
Smaller
smaller
charge.
magnitude. Correct. Charge of smaller magnitude. So you can see I have drawn the point P closer to what? And that's what you will get by calculation also. The charge will be closer to means the neutral point. This point is called neutral point. Okay, the point at which net force is 0 or net electric field is 0 is called neutral point. Make a note of that. The point at which net force is 0 or net electric field is 0 is called neutral point or null point. So because of this charge at point P, where will be the electric field, left or right? Electric field at point P due to this charge will be in which direction, left or right? Right. Because due to positive charge, it goes away. Okay? And because of negative, this is also positive. I thought that it's negative. It will be in which direction? Both of them are in opposite direction. So we'll do what? We'll equate. I don't know how to solve. You put the options, no, you can put the option and solve. You don't have to solve. For this MCQ, you just substitute the option. So no one got the answer. ठीक है. See, if you put 0.5 in this will become how much? Square root of 9? 3. So 243. So 243 is which power of 3? 5. Right? And you can write this as what? 3 square. 2 into x plus 2 is equal to 3 to the power 5. 5. That's all. Just you had, see, that's why 240 is given so that you create a multiple of 3 here. I think 0.5 should be done. You can solve it through the options. See, MCQ you can always solve through options. Full strength is coming for grade 10th for writing exam. 11th and 12th I have to search people. Yeah. What is the answer coming? Then calculate it. Solve it quickly. So because of this, electric field will be in this direction. Because of this charge, electric field will be in this direction. So E of Q1 will be equal to E of Q2. What is the formula? K Q1 Y. You can take this distance as x. So x square. This will be K Q2 by 2 minus x whole square. So K and K you can cancel. What is Q1? 4 microcoulomb. So 10 to the power minus 6 will get cancelled on both the sides. So this will be 4 by x square equals to 1 by 2 minus x whole square. Cross multiply. 4 into 2 minus x whole square equal to x square. What should be the next step? Square root on both the sides. So plus minus 2 minus x equal to x. So do the calculation for plus sign and then do the calculation for minus sign. You will get the answer.
Sir, is it 1.3 meter?
1.3. Okay, let's check. So if I solve for positive, 2 into 2, 4 minus 2x. Yes, 1.33 is correct. So x will be 4 by 3 or 1.33. So if this is 4 by 3, how much will be this distance? 1 by 3, 2 by 3. If this is 4 by 3, how much would be this? 2 by 3. Total distance is 2. So 2 by 3. 4 by 3 plus 2 by 3 is 6 by 3, which is 2. If you want to check for negative sign, you can check for negative sign also. So negative sign will be what? Minus 2 into 2. It will be what? Minus 4. Minus 4 plus 2x equals to x. So minus 4 equal to minus x. X is equal to how much? Is it possible? X equal to 4 will be outside the line. We are asking on the line. On the line, 4 by 3. All clear? Check. So we'll keep the physics still here. We'll start maths now. Next 5 minutes, we'll start maths. We'll start maths in 5 minutes. Anyone who wants a break can take a 5 minutes break. We'll start off. It's 25. Means you want to increase? You sit here, na? You are sitting just in front. That's why you're feeling cold. You sit on this. Here it's hot. That's why I put 25 room temperature. You can sit here. Question wrong, hai? Yes, what happened?
See, sir, I started it. I got the zero to the power of x equal to 0, sir, 3 by 2 and 1 by 3, sir.
Hmm.
So 3 by 2 plus 1 by 3 is 11 by 6. Okay.
It's okay. You can. If it is wrong, I'll give you full marks.
So see minus b by
I can't check now. It is exam.
Sir, please, sir.
You solve whatever you have done. If question is wrong, you will get full marks. And not get half marks also for you. Okay. What time kitna ho gaya, Suraj? I have to submit. It's 7:30. You came 5 minutes late. I gave you 15 minutes extra. बाकी का पेपर ले लिया सब कुछ स्टेपल कर दिया ठीक देखिए I'll give you marks if it is wrong. You don't worry. Isn't it done? Which who is that? What's it? No. Vote the marks. Who got 25? Let's see. How much Aditi got? Out of 40. In maths, I think 60 questions were there. 60. Chemistry, she got 27 out of 60. 40. This is for Aditi, right? It's correct for Kunal and this. in one paper, if you can't make Excel now, it's fine. Just at least in one paper, just write the name and write the marks. Ah, okay. Okay. Both of you are in same school.